Hi and welcome to Anju's Learn Point. So in the last video, we were looking at the register and memory organization in ARM. In today's video, we'll be discussing about an introduction to assembly language in ARM. So the contents which we'll be discussing today is regarding the instruction set architecture and the types of instructions. So starting with the instruction set architecture. It describes how the microprocessor processes various instructions. ISA or the instruction set architecture, it defines a set of native instructions to be executed. So it basically specifies the data types, the instructions, the registers, the addressing mode, memory architecture, interrupts and external input output. So ARM can be said to have two separate instruction sets. The first one is called the ARM instruction set and the second one is the thumb instruction set. So how is ARM instruction set different from thumb instruction set? In ARM instruction set, we can see that the instructions are 32-bit wide. Whereas when you look at the thumb instruction set, it is 16-bit wide. So that is how ARM instruction set is different from thumb instruction set. Now moving on to the types of instructions in ARM. The instructions in ARM can be categorized as data processing instructions, data transfer instructions, and control instructions. So we'll be looking at one by one in detail. First one is the data processing instruction. So these data processing instructions, it performs arithmetic operations, comparison operations, and logical operations. Mainly all instructions except the multiplication instructions are carried out in arithmetic and logical units. Only the multiplication instructions are carried out in a multiplier block, which is a separate block. Data processing instructions do not access the memory. That is one of the important points regarding the data processing instructions. Instructions mainly operate on 32-bit operands to produce a 32-bit result. So we'll see some basic operations in arithmetic operations. First example is add R0, R1, R2. So when we look at the first operation, addition operation, it is similar to performing A equals B plus C. So from this we can understand that R0 is our destination register, R1 and R2 are the source registers. So the contents in register R1 and R2 are added and the result is stored in R0. So the operation follows the addition, destination register and source register, where the destination register here is R0 and the source registers are R1 and R2. Similarly, there are various other variants of arithmetic operation. The next one is ADC. So in ADC, how is it different from add operation is an extra carry is being added to the contents in the registers and stored in another register. So we have the contents in one register added to the contents in the next register along with a carry which is added and stored in a third register. Next is the subtraction operation. So the first operation in subtraction is sub operand 1 minus operand 2. That is, sub instruction follows that the contents in the two registers will be subtracted and stored in the third register. Another variant of the subtraction operation is SBC, where a carry is involved and the operation follows operand 1 minus operand 2 plus carry minus 1 and the result is stored in a third register. The next set of operations is the comparison operation. So comparison is nothing but comparing the contents in the register. So we can see some variations of this comparison operation. So first one is CMP. CMP follows the operation operand 1 is subtracted with operand 2, that is operand 1 minus operand 2, but the result is not written. That is how CMP operation performs. Another variant is CMN, where the operand 1 is added with the operand 2 and the result is not written. Another variant is TST, where the operand 1 or the contents in the first register is ANDed with the contents in the second register and the result is not written into any of the registers. Similar operation is TEQ, where operand 1 is XORed. XOR operation is performed. XORed with the contents of the second register and the result is not written. So, some examples are shown below. First one is CMP R0, R1. So, the contents in two registers are compared by subtracting the contents and the result is not written anywhere. The next set of instruction is the logical operation. So, there are various logical operations and XOR, OR are all examples of logical operations. So, let us look at some examples. So, first one is AND. So, what happens is the contents in the first register are ANDed with the contents in the second register and stored in a third register. Similarly, EOR or XOR. Here also contents in one register is XORed with the contents in the second register and stored in a third register. Next is ORR, where the contents in the first register is ORed with the contents in the next register. Next is BIC, where the contents in the first register is AND not with the contents in the second register. So, how the expression looks like is AND R0, R1, R2, where the contents in R1 and R2 are ANDed together and the result is stored in R0. So, first we will have the operation followed by the destination and the source registers. Next is the data transfer instruction. So, data transfer instruction, from the name it suggests that there is some transfer that is occurring between registers. So, here we can look at some operations related to data transfer. So, first example is move. So, when we look at the example, we can see move R0, R1. So, contents in R1 is moved to register R0. So, this is one such example for data transfer instruction. The last category is control instruction. As the name suggests, it means that the control is shifted to a new address location and the execution will start from that particular location. That is, program flow, it usually follows a sequential order. But when it comes across a control instruction, what happens is it transfers its flow to a new address and starts its execution from that particular point. So, for that, certain instruction types are available. So, we can see that it depends on some conditional code flags. So, the conditional code flags are listed. N is negative or less than flag, Z is the 0 flag, C is the carry or the borrow flag, and V is the overflow flag. So, B loop A is one such instruction, which means that we have to, when this instruction occurs, we have to branch to label loop A unconditionally. There is no condition specified as part of the instruction. When you look at the other examples, we can see that they are conditional sort of control instruction. So, the second example, BEQ, target, means conditionally branch to the target when Z equals 1, or we can say that the 0 flag is set. Similarly, another example we can see is BNE AAA, that is branch to that particular location or label AAA when Z equals 0. BMI BBB, branch to that particular location BBB when N equals 1. N is the negative or the less than flag. So, these are some of the examples for control instruction. So, hope this video was informative. For more videos and updates, please stay tuned to Anju's Learn Point. Thank you.